Hello everyone. Our question for today is the following. We need to find the values of a and b such that this limit is equal to 1. Let us see what we can do. The first thing that we need to notice here is that a has to be positive. Why? Because in order for this limit to make sense, when x approaches 0 from the left, I mean x approaches 0 minus, t will be negative. Which means we will end up with a negative number underneath the square root, and of course, which is undefined. Thus, a must be positive. So that's the first thing we conclude. Next, I'm going to write this integral at the top here in the numerator. If we replace x by 0 at the top, this becomes an integral from 0 to 0, and of course it'll be 0. And the bottom is 0 minus sine of 0, that is a 0, and it's also 0. Which means I will end up with a 0 over 0, and I can apply L'Hopital's rule, which is the derivative over the derivative. To find the derivative of the top, we apply the fundamental theorem of calculus. So all we have to do is replace the t by x, and we get this expression at the top. For the denominator, bx becomes b, of course, and sine x becomes cosine of x. And this is what we get. Now let us put this square root at the bottom, so the limit looks like this. Now x approaches 0, which means the numerator approaches 0. Now for the denominator, we know that the square root of a plus x is positive. And we also know that the answer is 1. This means that we need to end up with 0 over 0. This factor must approach 0 as x approaches 0 in order to end up with 1. Because if this factor does not approach 0, we will end up with a 0 over a number that's different from 0, and of course it is 0. Thus, we must have b minus cosine of 0 is equal to 0, and b is equal to cosine of 0, which is 1. And now we can replace b by 1. Alright, we still have to find a. To do that, I'm going to use the Maclaurin expansion of cosine of x, which is this formula, and it is valid for all real numbers x. So we plug in this expression into cosine of x here, and this is the expression we obtain. Now, of course, we have to distribute the minus. This means that these ones are going to cancel out, and all the signs inside will change, and that's what we end up with. Now the next step is to factor an x squared here, so this is what we get, and we can cancel x squared with this x squared. This is what is causing the 0 over 0, I usually call it the annoying factor. Moreover, this goes to 0 as well as this and everything else here, so we're only left with 1 over 2 factorial inside. This also goes to 0, so we end up with this simple equation. Let's write the 2 factorial at the top, and we got a. A is equal to 4. Thank you for watching, and see you in the next video.